Hey everybody, welcome back to the video lectures for Unit 4. Here, I'll put the cover slide up so that you can see it. This is Unit 4. And in this video, we're going to be talking about Chapter 27, and that's covalent bonds and something called polarity. It's probably no joke here, or no secret, that we've been talking about electronegativity a lot. There's other periodic trends, but electronegativity seems to be the one that we end up talking about a lot because of its importance in compounds. And so, what this all comes down to, again, like the type of bond, whether it's ionic or covalent, when we have two different types of covalent bonds, the choice is made by electronegativities. Okay. If it is a covalent bond, well, first let's deal with ionic bonding because that's not mentioned here. There's only really one type of ionic bond. Okay, the electrons get transferred. It's an attractive force between the positive and the negative. It gets transferred because of the huge difference in electronegativity. So this is fine. Okay, but it's this covalent idea here where we're sharing. Now, here's the idea. Let's say we have two elements that are exactly the same. Let's say we have nitrogen, and it's bonded. That line I'm going to represent as a bond, bonded to another nitrogen. Okay, nitrogen has an electronegativity, I think, of somewhere around 3.0. Okay, and again, I'm never going to make you memorize electronegativities, no matter what. Now, electronegativity is the desire for atoms to want to get electrons or pull electrons toward them in a molecule. So, here's two nitrogen atoms, and this bond has electrons in it. Okay, there's electrons here. There's actually two of them in here. Well, for nitrogen it's more than that, but anyways, the point is that there's electrons in here. Okay. If there's electrons in here, which atom are they going to favor more heavily because of its electronegativity? Well, because nitrogen is the same, they're basically in a tug of war. Do the electrons want to go here? Do the electrons want to go here? Well, the electrons want to stay in the middle because they are equally powerful. Okay? And so there's no preference here. And so this is called a nonpolar covalent bond. It doesn't have two sides. Something that is polar is something that has two sides. And so there's not a preference to the sides. Now let's talk a little bit about polar covalent. Okay? Because what if we have something like carbon bonded, and I'm going to just show the electrons here as a line, bonded to chlorine. Now, carbon has an electronegativity of 2.5. Chlorine has an electronegativity of somewhere around 3.5, something like that. I don't know, somewhere around there. But the point is their electronegativities are different. Okay, it doesn't even matter how different they are. So they're close enough that they're still sharing the electrons. Remember, if the electronegativity difference is huge, then these two things, then it's gonna be an ionic bond. But so this electronegativity difference is close to make it covalent, but it's not that close, meaning the electrons here are now going to have to pick. And how are the electrons going to pick which atom they like better? Okay. Well, they're going to look at they don't look at the electronegativity, but we as chemists are going to look at the electronegativity. And it turns out that because chlorine has a higher electronegativity, the electrons here are going to be around chlorine more than they're around carbon. Okay? And it's kind of like a parent example. Okay? If both parents are equally awesome and they're equally awesome with a 3.0 or a 2.8 or whatever, okay, the kids, the electrons in the middle, are going to share time equally between both parents. Okay? married, unmarried. It doesn't matter what the parents are, married, unmarried, whatever. Okay, but the point is that the parents are equally awesome. Okay, now we have a case where, let's do carbon and fluorine, where one parent is a little more awesome than the other, 4.0, carbon is 2.5. So again, they're still close enough. They're still kind of equally awesome, so that they share the kids. They're still kind of together, but which parent is more equally, which parent is more awesome? Fluorine is. So the kids are kind of going to gravitate around the fluorine a little more than they're going to gravitate around there. Everybody still meets. Wow. I don't know if you picked up on that, but there was loud sirens. Anyways, the fluorine, the carbon is going to still have the kids, and the fluorine is still going to have the kids, but the fluorine is going to have it a little more often. They all sit around the table, okay? They're all part of one big family. It's fine, but the point is that the electrons are going to be more around fluorine. They're going to be not as equally shared, okay? So, that is the two types of covalent bonding and how we can tell the difference. And it all relates back to that crazy periodic trend, or that crazy property of an element that we can tell from the periodic table, which is called electronegativity. Okay? So, have a great day.